underwater compasses and navigational instruments. Another technique of underwater navigation, particularly valid in environments with no reference points, consists of using instruments that aid navigation. A compass and a depth gauge enable us to deal with many situations, transforming the anxiety of not knowing into awareness of knowing where you are and the safety of being able to return to your starting point. For example, by just using a depth gauge, it is possible to follow a bathymetric route on a sloping seabed. Staying at the same depth for both the outward and return leg ensures that the return leg will be very close to the outward one and take you back to the starting point. Adding a compass enables you to deal with most situations. Modern diving compasses consist of a magnetized rotating face that feels the effect of the Earth's magnetic field and are immersed in a liquid which deadens the movements and steadies the rotation. All this is contained in a case with a transparent window, so you can see the rows and read the direction. A line, known as a lubber line, is marked on the window, and this represents your direction of travel. There is usually a viewer on the casing, and this allows you to read the direction while holding the compass at eye level. On the upper part, a rotating bezel is used to memorize the position of the compass rose, so you can stay on a constant course or vary it. Having established a direction, to set the compass, it is enough to just rotate the upper bezel so that it coincides with the north mark of the compass rose. So to stay on course, just swim while keeping this as a constant reference point. Navigating with a compass can be very precise, but it must be used correctly. One of the errors to avoid is that of starting the course in the wrong way by not aligning the lubber line and the direction of travel correctly. This lack of alignment can occur, for example, because the compass is positioned incorrectly. One of the most common ways of using a compass worn on the wrist is to extend your arms in front of you and then bend the elbow with the compass and take hold of the elbow of the arm without the compass. In this way, the lubber line is aligned with the extended arm and, consequently, with your body. Instead, when using a compass mounted on console, you have to hold the instrument and extend both arms in front of you or rest both elbows at the side of your body. In this way, a perfect triangle is formed and the lubber line is aligned with your body. It is possible to use a combination of navigational techniques, combining the use of the compass with natural reference points and the depth gauge. The route is calculated mathematically. To obtain a new heading after each rotation in a clockwise direction, you must add to the previous angle of rotation. On the contrary, you must subtract when turning in an anti-clockwise direction. Let's look at a practical example. Starting with a heading of 040 degrees, by adding 90 degrees, the second leg will be 130 degrees. So set the bezel to 130 degrees and turn until the compass is aligned to this value. You can now swim in this direction. With another 90 degrees, the next heading will be 220 degrees. Another 90 degrees gives us a heading of 310 degrees. Repeat the maneuver. With another right turn, so adding another 90 degrees, we get 400 degrees, which is not marked on the compass, but by subtracting a complete rotation of 360 degrees, we get our initial heading of 040 degrees. With a compass, we can make complex routes. Obviously, we must measure the distances of each leg using one of the methods we have already mentioned. In a similar way to how we made the alignments, it is possible to fix a position with two bearings. Just identify two conspicuous points and, using a compass, determine the heading to follow to get there.